In this section of ALEKS College Algebra, we will be looking at solving a word problem using an exponential equation type 2. And as we look at this, we can see that it's similar to what we did before. We have a loan of $45,000 made at 6% interest compounded annually. After how many years will the amount reach 70,000 or more? And so we can see that this is similar to what we did before, but of the more complicated type that I think I referred to in the notes. Let's take a quick look at our notes here and remember that we're going to be using the compound interest formula, and like before in the earlier notes, all of these same things apply. The A is the amount of money at time t, beginning balance is P, R is the rate, N is the number of times per year that we compound, and T is the total time in years. So let's see if we can then read our problem and come up with these amounts. So as we pop back over here, notice that this loan of $45,000, well, that is P, our principal. It's made at 6%, 0.06 is the rate. After how many years? So T is unknown this time. Will the amount reach $7,000 or more? And so what we're looking for here then, this is the actual A number. So we want this to be plugged in. Let's go over here and do that on our notes. And so plugging what we have this, because this amount A is going to be $70,000 or more. Our principal here, our interest rate here. Notice that we're doing this annually, so our N is 1 times T. So what we can do is to clean this up a little bit. Let's take a step and just simplify. So 70,000, we're going to have 45,000. This is just 1.06 and then to the T power. So we have this step. My advice to you here would be to divide both sides by the 45,000 and try to isolate this exponential term. So if we simply grab our calculator here, 70,000 divided by your 45,000 turns out to be 1.555 repeating. Let's make a note here. And so let's just go ahead and write that all down. Okay, and so we will write a step that looks like this, and I'll maintain this number on my calculator here. Okay, now at this point we want to solve an exponential equation. In the past, what we've done here when we had nice whole numbers was to try to get these bases to be the same, but that's not going to be so easy here. Although the trick that we're going to do next actually accomplishes that, and what we're going to really do then is to make both of these bases be 10. Okay, we'll simply use logarithms though to do that. So at this stage, the trick: take the logarithm of both sides. So let's write a step that we're going to take the logarithm. We'll use the base 10 logarithms. Okay, so the base 10 logarithm of the left, the base 10 logarithm of the right. So we will have this 1.5 repeating number here, and we will have 1.06 to the t. Now immediately though, on the right hand side, notice that one of the rules of logarithms is that when you take the log of something to a power, the power comes down front. So immediately this t comes down, and we have the log of 1.06 over here, the log of 1.5 repeating. So I can write this step. I can see now that I can solve for t, because what we're going to do here is to simply get it by itself, which is going to be the log of 1.5 repeating divided by the log of 1.06. So we can get to there. And now we'll simply grab our calculator and we're ready to crank. So we're going to take basically a fraction. We're going to take the log of the answer that we got, so we can hit second answer here. That's going to put that 1.5 number in there. On the bottom, we are going to take the log of 1.06. And we're going to let the calculator crank. Notice that we get 7.58 8. Let's make a note here. So we're going to have 7.5826 and some other decimals equals t. Now we need to read carefully here, because while we have the answer, I'm going to see what ALEKS wants here. Notice the answer that we want to have as a whole number. Okay. Now obviously here, as your interest compounds, okay, we're going to get more and more and more money in the bank. So notice that we will hit the 70,000 exactly at this number of years. And as time goes on, we will have more and more and more money, so 70,000 or more will occur when we round this up to the nearest year. Since they want that to a whole year, we will need to round up. And so let's say 8 years, and let's check it. And ALEKS is happy.